Perfect. So today we would be talking about SD-WAN Viptela. Okay. So I hope you guys are aware SD-WAN Viptela, why it is named as SD-WAN Viptela, because Viptela Inc. was the organization which developed the SD-WAN terminology, and post that Cisco acquired it. Okay. Since Cisco acquired it, now currently it is named as Cisco SD-WAN Viptela. Okay. So we would be talking about Cisco SD-WAN Viptela in today's session. Okay, so let's maybe start up with why we required the SD-WAN. If you will talk about, everybody is talking about these SD things, right? SD means SDN, software defined network. So either you call about the ACI, other you call about the SD access, either you talked about the SD-WAN. Okay, so in data center, we have ACI. In LAN side, we have SD access. In WAN side, we have SD-WAN. Everywhere this terminology is coming. SDN is, nowadays populating. But why? What is the requirement? Any clue? Okay.
I believe nowadays network become more complex and it need to go through a private line also. It need to go to broadband also. Sometimes they need to compromise on bandwidth because of private network having less bandwidth. So they need to go to internet for some time. Some things are hosted in your own data center. Some things are hosted in cloud. So it become very complex nowadays to make a network without with all the control you having with routing and switching. So you require some software in it that can control everything with it. So this is my opinion. I don't know exactly.
Yeah, that is correct. It is really a common sense thing, whatever you are telling. That in recent years, business is really transforming. Everybody is going to the something named as digital. Everybody has some kind of app for their application. Even if there is a teacher, they have app. There is a doctor, there is app. There is a maybe a simple shopkeeper, they have the app. Okay, even the cleaning persons are going with the app. So see, the business is changing rapidly than ever expected. Remote working, online meeting are now the standards, right? Especially after the COVID. So every application now moving to either to the public cloud or maybe over the internet. So company wanted to reduce their cost. They wanted to manage their infrastructure more effectively. Okay. And traditional WAN does not support these kind of things. Why? Why? Because you require the dedicated release line, you require the MPLS circuits. Okay, if you wanted to have one-on-one communication, sorry, the private communications, you could see that in your organization still you could see the lot of MPLS connections and all of these things. But now things are moving literally somewhere over the internet, on over the public cloud, and maybe different underlay network, I would say. So what happened is, earlier everything went to your data center, and from your data center it moved to everywhere, either maybe on the cloud, maybe anywhere if you wanted to go. But now the things are getting changed. Even if you are home user, it can go to the internet, it can go to the cloud directly. If you wanted to go to the data center, it can go to the data center also for the enterprise purpose. But it is not must that you need to be go to the data center first. So it is reducing the cost, right? Cost is getting reduced now. Why? Because MPLS, if you will see, MPLS is really expensive rather than your internet, right? Now if you will talk about the latency, see about the latency. If you are using Office 365, if you are using some kind of maybe cloud based application, I would say you need not to go to the data center and from the data center go to the applications. No. Currently, even if you are having the in small office, home office, or maybe in the remote side, or maybe anywhere, you can directly go. You have that kind of functionality available in the SD things. Okay, so we can say reducing the cost. We can say high latency was the problem earlier. Now the latency is getting reduced, and improve the uptime. Centralized management is there, automation is there. So cloud is like sorry, the SD-WAN is bit like if I will talk about the automation, you can implement the things very fast. Secondly, what about your wrong designs earlier? What about the new people are coming in the team and they are doing the misconfiguration and the deployment is getting, failed? No, 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 no. Currently, there is nothing such things happens. What is the main thing is automation. So on the basis of automation, it is really very much focused on automation. But why? How it is, working on the automation? What is the main idea? Main idea is they have different planes. Planes are now, segregated. So if I will talk about management plane, probably I would talk about the other planes in a while. But if I will talk about the management plane is the centralized now, right? You are aware about it? Yes or no? Are you aware about management plane, data plane? Guys, anybody?
Yeah,
No?
management plan will be the network that is specifically designed to manage the equipment, I guess.
Right,
Uh,
right. That is our management plane. Now, if we will talk about the management plane, there is a centralized management plane. It means for whole of the topology, there would be a single management plane. And since there is a single management plane, we can achieve the things through the automation. Okay. And also because we can have the single management plane it is more secure. First of all, okay, it is more secure, it is more flexible. Okay, if we talk about the scalability is also good. Why? Because you have the single management plane, you have the control plane differently. You can control the things from the controllers, something named as controllers. I would be going to talk about that. Okay, but okay, let's first stick to it. So if you talk about why SD-WAN, SD-WAN for more security, for better analytics, for more velocity, lower latency, high availability, reducing the cost. These are the primary functions which everybody knows nowadays, right? I hope there should not be any issues in these small things. If you have, please do let me. So we can say SD-WAN is designed to address the challenges which were there in our traditional WAN. So SD-WAN is one thing like which decouple all of these planes. Now let me tell you. Okay, maybe you guys are aware that what happened is, let us say we have some routers, okay, in our traditional WAN. Okay, and we are running out some of the protocol BGP, EIGRP, MPLS, whatever, or VRF Lite, whatever protocols you are running. Every router will make their own decision because every router has their own routing table. Okay, they have their routing table. So it means they have their different control plane. They have their different data plane. Okay, they have their different management plane. So everybody was doing everything. It's a bit like that every person is doing everything. And when such a case, every router matters. But now the thing is SD, when we are talking about SD, what SD does is SD just separate this plane. It says no, management plane would be different. If we will talk about the management plane, different. If we talked about control plane, different. If we talked about the data plane, different. Probably I would be gonna give you these examples a little bit later, but just I am saying you that it decoupled everything. Okay, now let's proceed further. Here in this slide, if you see, we can check that Cisco offer two different type of SD-WAN products through its acquisitions of Meraki and Viptela. Okay, both products are fully fledged SD-WAN solution. And there are some features in one of them which does not support by the another one. Like Cisco made it clear that Meraki and Viptela are geared towards the two different markets. What are that? That Cisco Meraki, if we talk about. This is designed for small organization, or maybe we can say mid-sized companies that want simplicity and ease of use of above everything else. So SD-WAN solution designed for smaller companies or is Cisco Meraki. So that is the right choice for them. But if we talk about the greater enhancement, the advanced features, and if you have a sophisticated network design and a long architecture, in that case, if you have large scale enterprise solution, you need to go with the Cisco Viptela solution. If I'm not wrong, if you people are aware about IWAN, earlier Cisco was, selling out the IWAN solution also before SD-WAN Viptela, or before SD thing. Okay, they were proposing that solution, but it's all right. We will be going to talk about SD-WAN over here. Now, let's come to this. I was talking about this stuff. Okay, when I was saying that every router was doing everything by their own, but Cisco solution, what it does, it segregated the 4 plane. You can see the first plane is the data plane, second plane is the control plane, third plane is the orchestration plane, fourth plane is the management plane. Okay, all of these 3 planes, if you see the top 3 planes, these are coming in something named as controllers. And when you talk about the data plane, it is something named as WAN edges. Okay, so when we are talking about WAN edges, it can be C edge, it can be V edge. So if it is Viptela device, it is named as V edge. If it is Cisco device, it would be named as C edge. Okay, like Cisco ASR routers or ISR routers, you can just change the image and you can use them as a WAN edges for the SD-WAN Viptela thing. Now, if you guys able to see here in this picture, this is complete a fabric. It is complete a SD-WAN fabric. What happened is, if you remember your chassis, like switches, like 6500 switches or the other switches, you have the control plane separately. Okay, you have the data plane separately, management separately, but this is the whole fabric. This is the whole chassis which is acting as a whole fabric. Here, this complete solution is acting as a one fabric. Although there can be, it can be over the MPLS, it can be over the internet, 4G, 5G, whatever media, hardly matter. But this completely make a single fabric in SD-WAN case. And what happened is, whenever your device comes, okay, it can become the part of this fabric. Probably I will explain like how it will be become a part later on. But currently, let us stick to this, this solution. So if you see, what happened is, we have, as I told you, couple of controllers. These controllers, for the management plane, there is a separate controller named as vmanage. And this controller is only for the management perspective. Let me show you the lab, and there probably you could make it, more, you can understand it properly. See, this is our lab. Probably I would be gonna describe about the lab later on, but you can see this is the controller too. In the controller, this is your vmanage, vBond, vSmart. It can be on any of the cloud probably. So I just separate it on some another cloud over here. Now, if I need to take the like access of it, I am just going to this PC. Okay, let me log in into this PC. Let me make it maximize. Going to the GUI. By the way, it is GUI thing. Okay, you can log in through the CLI also, but majorly you will work on the GUI. Now, if you will go to the controller, this is vmanage. You can see Cisco vmanage. Okay, so if you go to the controller, you could see a very fine dashboard. This is your dashboard. This dashboard is showing you there is one vSmart, there are 4 WAN edges. If you click over here, it would be gonna talk about, okay, what are the WAN edges. Now it is talking about the vBond is there, and there is vmanage. So this vmanage is a management plane. From here itself, I can do a lot of things. Probably I would be going to explain later on, but you can see that all of the devices are there. If I need to check this device, okay, I will go to this device. I will just scroll it down. Probably I'm just showing you one thing. If I'm going to the real time and just showing you the OMP, maybe received logs. Okay, what are those? I would be going to explain you later on. But you can see that from here only I can do each and everything. Okay, I need not to go separately on separate device and check the stuff. No. This times it is single management. So in this is our V manage. Okay, if I will come back to my slide, so management plane is now segregated. Who is handling with the management plane? We manage. So we manage your everything. Either it is vBond, either it is your vSmarts, either your WAN edges, either you need to do with some kind of analytics, you could do. Also, on the top of that, it is a GUI thing I showed you, and you can write down your own automations also. Although Cisco also provide you the automation over here. Okay, there is southbound API calls which used to be keep on running in between your vManages and different components of SD-WAN architecture. But later on, I would be going to explain you about the same in our classes. Currently, you can just think of that there are 4 separate parts which is getting divided off to make the things easier to have the proper management of the SD-WAN fabric. Any doubts so far from anybody? Please ask.
No.
Okay. Let's go further. So this is all about our management plane. If you see in the controllers, there is a control plane. What is this control plane? This is Cisco vSmart. Okay, the vSmart is again another controller which is used to control everything, and it is dedicatedly used for uh, control traffic. Okay, dedicatedly for the control traffic on. So this is one thing. Now what happened is whenever there is SD-WAN fabric comes, okay, whenever the SD-WAN traffic comes, this is your vSmart. What happened is every device will tell its information to the vSmart. Which information? Probably I am hiding that part currently because you are not aware about the T-logs. I would be going to explain about it. Okay. So it will explain some information to vSmart. vSmart will give that information to different other WAN edges by default. Okay. This is by default stuff. This can be manipulated as the traffic engineering, whatever you want in your environment. But by default, this is the way. Like some information will go from one WAN edge, will be cascaded to other WAN edge. So who is controlling? vSmart is controlling. Okay. So vSmart is the one who is acting as the control plane in case of your SD-WAN system. vSmart can be considered as the brain of the overlay fabric. All the fabric brain is vSmart. It advertises the routing, it advertises the policy, it advertises the security to different WAN edges. Even if you need to go from this WAN edge to this WAN edge, maybe if I will talk about the user traffic over here, which is named as service VPN traffic. So if you need to move from here to there, then also you require the information of the routing from the vSmart only. It is bit like your BGP route reflector. What route reflector does? It provides the information, the control plane information from one BGP peer to the another BGP peer. Similarly, in case of vSmart, such things happen. Any doubt to anybody? So this is vSmart. Now, when we come to the WAN edges, I told you these are in the branches where you have the actual traffic. Okay, probably I would be gonna explain about these things in a while. Okay, so maybe let me tell you. Let me just make a picture over here. What happened is, let us say you have one branch. You have second branch. On this branch, you have, let us say, one VPN. VPN is bit like your VRF. Are you aware about VRF, guys? Yes or no? Come on, yes or no? Yes, from Vani. No. Okay. So this is your service VPN. This thing is named as service VPN. Let me tell you VRF. VRF is bit like the segregation of your routing information. Let us say if you have a router, in this router, you wanted to have two subnets, 10, 10, 10, 0/24 from two different users, or maybe you can say from two different partners. You cannot configure them, you are aware by default. What you need, you required something named as VRF. VRF is bit like your VLANs, like your VLANs separate the LAN part into two VLANs, three VLANs, four VLANs. Similarly, you can use VRF. So if you will use VRF A here, VRF B here, it will append your 32-bit with 64-bit, okay, and named as VPN v4 traffic. If you remember, it can be again goes up with your bit like maybe, you know, simple like a VRF Lite, or it could be your what you can say the MPLS traffic also. Okay, so it all depends how you are using the VRF, but VRF thing is bit like that you are having separating the routing table. So Cisco SD-WAN uses the same thing. It is named as VPN. So you have couple of the VPNs available. One of them is service VPN. Okay, let me tell you, VPN 0 is the transport VPN. Transport VPN means where your internet, MPLS, these kind of transports are connected. Then from 1 to 511, it is service VPN. Okay, service VPN means where your client traffic can come. 512 is the management VPN. So earlier there was till 512. Now there are more. So above 512 also can be considered as service VPN nowadays. But earlier they just considered till 512. So it was only 511. 1 to 511 considered as service VPN. If you see here, there is service VPN, there is a service VPN. Okay. Let us say this device is connected over the internet. And okay, this device is also connected over the internet. They are going to the vSmart. Okay, fabric is up, everything is fine. Now you see what happened is this is the part of VPN 0. First of all, transport VPN. So this will be the part of VPN 0. Okay, and it will have something named as TLOC. TLOC, you guys will able to understand what is the TLOC is. Very simple thing. Probably I would gonna explain about the TLOC in a very great extent for a 1 hour session or 2 hour session, but currently it is demo. I cannot explain everything in 15, 20, 30 minutes. So I am just bringing it up in very high pace. So let us say it is your TLOC. TLOC containing your three information that, okay, this is over the internet. Okay, it is over the internet having the IPsec tunnel. Okay, and this is containing three things. Okay, one is system IP. System IP is bit like your router ID. So let us say the system IP of this device is 1.1.1. It has that system IP 1.1.1.2. So this is something named as color. Color is the tag. This is something your encapsulation. Encapsulation is bit like your IPsec or the simple GRE. And one thing is your system ID. So system ID is your 1.1.1.1. So this is a T-log information which is generated by your router 1, let us say. This is your router 2. Router 2 will also generate the same information. It will say my T-log is 1.1.2. My color is internet. Okay. And my encapsulation is again IPsec. This information will go to the vSmart, and vSmart will cascade the information of each and every router to other router. So this router 1 will able to understand that there is 1.1.1.2 which is active on the internet and running on the IPsec. So later on, if there is some requirement that service VPN traffic is coming from one VLAN to another, these two guys can create a tunnel, or maybe I can say an IPsec tunnel in among each other using the vSmart, because vSmart is the one who is cascading this information from one router to the another router. Now let us say in this scenario there is some change, and what kind of change is this particular router 1 is having the connectivity with MPLS also, with having MPLS also. So MPLS traffic also go to the vSmart. Now this particular router R1 will generate two T-logs. T-log is service like it is your site ID. Okay, it is your like ID, bit like your router ID. Okay, you are just putting it 1.1.1.1. The color is MPLS and encapsulation is IPsec. So vSmart is able to understand that this particular device R1 is having the control connection over the internet and over the MPLS both. If you check our topology, okay, if you check our topology, this is our topology. In this topology, you can see there is a site 150. In the site 150, there are two colors which are up. One is it is going to the MPLS, one is it is going to the internet. Although my every site has two connections, but the red lines are representing that by default, I am not making them up. And why? Because they will come up when we learn about something named as policies. Okay. So policies is the heart. When you will learn the policies, you will be able to understand that, okay, why SD-WAN is, why the people are saying SD-WAN is very easy. Okay. In terms of configuration. Otherwise, without policies, you will feel so that SD-WAN is doing nothing. SD-WAN is just increasing our time to configure something. Why? Because you cannot configure this device by your own once it is associated with the vManage. It has to be configured. Anything, even if you need to change the host name, that has to be configured through the vManage. You cannot go directly on the vEdge and change the host name. You cannot. So you will feel like that, okay, this is increasing the complexity. This is increasing the time duration of the configuration. It is literally delaying the things. But no, when you come to the policies, and let us say by default, what happened is every device will make the connection with other device. So this device will make the connection with it. This device will make the connection with it. This device will make the connection with it. Something named as full mesh. Okay. So by default, everything is full mesh. Everybody is trying to reach everyone. But let us say there is a very simple example. We wanted to make it as a hub and spoke, bit like hub is my DC, spoke is my every branch. So I want every branch should go through the DC if they needed to communicate. When it is a traditional WAN, I need to do the routing over here. I need to do the routing over here. I need to do the routing over here to make this thing happen. But now, in case of SD-WAN, only I will go to the vManage, configure a policy. That policy will go to the vSmart, and vSmart will take the routing decision or the control decision by its own. It will push wherever it need to be get pushed. Not only this, probably we need to add some Ethernet routing. Probably we need to do some kind of service service insertion routing. Such kind of policies, when come into the picture, you will feel like that SD-WAN is really making the sense. Okay. So how what I was explaining earlier, I was explaining about this T-lock information, and I was saying that this information is going to the vSmart. But who is bringing this information to the vSmart? There is a protocol named as OMP. Okay, overlay management protocol. Again, I am telling you, I cannot explain everything in a small time of duration. So I am just picking up the speed just to show you the demo, how it works, so that you can understand a couple of the things. But I cannot teach you everything in these 30-40 minutes. Okay, these classes are very deep classes. When we read about the OMP, when we read about that, okay, what kind of the routes are there in the OMP? There are three types of route. One is your OMP routes, one is your T-lock routes, one is your service routes. So this T-lock information when goes, it is named as T-lock routes, one kind of route. These routes, when it is going to the vSmart and going to the another side, these are named as OMP routes or the service VPN routes. If there is some kind of firewall, there is some kind of probably maybe load balancer or something, some kind of technology is there. When these routes will go to that side, these are named as service route. So all of these routes cascading information is the responsibility again of your vSmart through the protocol name as OMP. When you will see the OMP, it is bit like your maybe BGP protocol. I could show you a couple of things. If you see in my dashboard, okay, one control plane is down. Can you see? It is showing me that, okay, 230 is unreachable due to some issue. So if I will check, where is my 230? This is my 230, probably it is up, but maybe let me just stop it and make it up again. But meanwhile, let me show you something. You guys able to see that here in this picture, we can see about the reachability that, okay, these devices are reachable. What is the host name it is telling? What is the system IP about what I was talking about, that it is bit like your router ID? What is the site ID? Site ID, maybe I will gonna explain about the site ID, system IP, all of those things later on. What is the device model? Then the BFD work over here. Very fast protocol. You are aware that BFD can work anywhere in the EIGRP, also in the BGP also. So BFD does here two work. One thing is it is really fast. It act for the keep alive and everything. Second thing is it let me go down. It bring out the information like which device has what is the latency, what is the average loss, what is the jitter, and it provides some kind of reporting system to you. On the basis of that reporting system, we will work on some of the policy named as application aware routing. Very important again. Application aware routing is bit like which link is good for me for my application. Let me give you an example. Okay, let me give you an example. Give me a minute. Let me give you an example. So what is application aware routing is? There is a WAN edge. In the WAN edge, I have two links. One is the internet, one is the MPLS. Now, my application is really very, very sensitive. So if my MPLS is congested or it is not under the SLAs, whatever I am applying for, then automatically my traffic will go from the internet. But once my internet is out of the SLA and it is slow, it has a low, the jitter is getting high, or maybe the latency is getting increases. In that case, my traffic again move to the MPLS. I need not to do anything. There is no manual intervention required. Everything does by its own. Okay, something named as application aware routing. Very simple policy when you will push it from the SD-WAN. But in case of traditional WANs, if you wanted to write down such a program, okay, this is nothing but the program, or maybe you can say the scripts. Okay, when you need to write down such kind of scripts, it is really, really hard. You need to do a lot of things over there to make it happen. But in case of SD-WAN, it is really very easy. Okay, maybe if I need to tell you about the like WAN edge, let us say there is a WAN edge. You wanted it to join with the fabric. In the fabric, there are the controller zone. Okay, there are three controllers. You are aware now. One is vBond for the orchestration plane. Orchestration plane means for your first time orchestration plane is the one which will make you aware about the other controllers like vSmart and vEdge. So if you have the some vanilla configuration named as the bootstrap configuration. So if you have the bootstrap configuration on this WAN edge, this WAN edge have the internet connectivity or the MPLS connectivity, whatever, this device will automatically go. Okay, it will automatically go to the controllers. It will associate it with the vBond. It will get the information to the vSmart. It will get the information with the vEdges automatically. You need not to do anything. So that is happened automatically by its own, and this is really a zero trust we can say procedure. So this is something named as PNP. Okay, very easily you can able to log in into the device by your own self. It will get authenticated with the certification and every stuff. It will make in the go in the SD-WAN terminology, and it will learn about everything by its own, and that is really a very fantastic stuff in the SD-WAN. Probably I would be going to talk about this ZTP, okay, the stuff, zero touch provisioning or the PNP provisioning later on. But for now, you can just understand if WAN edge router is coming up, okay, either it is physical or virtual appliance, any appliance it can be. When you are just putting it on, there is a process called as ZTP, okay, zero touch provisioning. Nowadays in the Cisco, it is named as PNP, plug and play. Okay, so this means these both terms are interchangeable. Okay, so this means that you are just putting your device in the WAN edges in the internet or in the MPLS, and automatically it will become the part of SD-WAN fabric. Okay, so that stuff will happen automatically. Now what I was explaining is, let us say you have some devices. If you go here, you can see there is OMP, like how many OMP are there. If you see the OMP, there is one OMP. Okay, why? Because we have one like control plane. There is only one vSmart. So if I will go to any of the device, let us say I am going to some of the device. I am going in the networks, and in the networks, I am going to the 120. Okay, and here I am saying that, okay, let me go to the real time. I am saying OMP and PS. Who is my OMP peer? You can see there is one vSmart, and that is showing that, okay, this is the OMP peer. It is in the site ID 100, state is up, blah, blah, blah. There is lot of information available. Okay, now if I will go to the dashboard again, you could see by default, as I told you, everybody will make the everybody will make the tunnels with each other. So you can see there are the BFD is bit like your IPsec tunnel is coming up. So if I will go to the 150 site and I wanted to see like what are the tunnels that it is creating, you can again go to the go over there in the networks. You can check each and everything. But let me show you something else. I am going to the 150 site. Here I am going to the troubleshooting. In the troubleshooting, there is something named as simulate flow. I am going for the service VPN 10. I am saying for my service VPN 10, I want to simulate the flow, and I want to check if I need to reach to the destination 172.16.1.1, what are the flows available? What are the routes available? When I simulate this, it is not presenting me anything. And because reason is my firewall is down, and my firewall is supposed to send these routes. So let me make this firewall up. Once my firewall is up, you could see these routes can come from any of the one direction. It can come from, this is my data center, by the way. This is my data center. This is my site 150. 150 has two links. Data center by default have the internet link also and an MPLS link also. If both of the links are up, it will be having 4 routes. If only one of them link are up, it should have 2 routes available. So that is what I need to check. Maybe let me simulate this flow again if my routes are there. Okay, and here you go. So you could able to see, I can simulate the flow from the GUI thing. So currently my MPLS and internet link is up from one of the data center. Okay, so let me tell you how this thing is happening. Okay, let me show you. Probably you will make it more out of it. There is a site 150. There is a data center. In the data center, there are two routers. One router is having the internet link. One router is having the MPLS link. Both of them connected with the firewall, which is giving a service link as 172.16.1.1. 150 side is having the internet also. 150 side is having the MPLS. And that is the reason when I checked that I wanted to go to 172.16.1.1, what are the links available? From internet to internet, it is giving me one link. From MPLS to MPLS, it is giving me one link. So it is simulating me two links. Now it will make more sense. You can see it is giving me two links. Getting this point, guys? Yes or no? So let me check if there is some policy applied over. Okay, there is some policy. Let me deactivate it because it is showing me only, it was showing me only one data set. Okay, so let me deactivate and do this stuff again. If my both of the links are up, it will show me 4 links now. Let me show you. I am going to the troubleshooting, going to the simulate flow for VPN 10. Okay, I wanted to check this route, simulate the traffic, and this time you will see 4. And the reason is because now I had make MPLS up with it as well. I have make internet up with this as well. So internet connection would be 1 and internet connection would be 2. MPLS connection is 1 and MPLS connection would be 2. So there would be 4 links now. So you could see the same. With 121, there is MPLS connection. With 121, there is internet connection. With 122, there is MPLS connection. With 122, there is internet connection. So you could see, you can reveal the picture that how in the SD-WAN, things are little bit different. By the way, you guys need to make this fabric by your own. You need to make this fabric by your own self. You need to make that up. You need to do the practice by your own. You need to do the certification part by your own. You need to do the template part by your own. Then when it comes to the topologies, you need to do the topologies by your own. Everything will be done by you. You need to make your hand dirty. You need to go there. You need to learn about the things by doing the practical. So that is the way, like it would be very different when you will understand the concept by doing. Okay. I hope for today we can wrap it up over here. Okay. But if you have some questions, I am feel free to ask. I am more than happy to answer. Any questions from anybody?
How this all the vBond, vSmart, how these devices are interconnected? Any separate internet link is there between them, or it is connected with MPLS or anything that is already available in the network?
These are cloud based. Okay. So you can put it under the cloud. You can put it under the maybe your own premises also. You can put maybe under the VM. Okay. These are the software things. So yeah, there should be some link. There should be some link. Either maybe MPLS, either maybe internet or whatever. So MPLS nowadays, if you will see in the SD-WAN, we are less concerned about that, about the underlay, I would say, transport. It can be anything. It can be internet, it can be MPLS or anything.
Okay.
Okay. So these devices, I hope you are aware, just you need to start it by clicking right click. Okay. And these devices will get boot up. When you double click, you can take the console of it. So you can see this is a WAN as which is getting booted up. Okay. So this is very simple. Lab is very simple. Whenever you are doing the lab, lab is very simple and you can do it. Maybe currently it is not initiated. Even if I try to log in, it will say that it is not initiated. See, system is initializing. Please wait to log in. And it will throw the error that it is authentication failure, whereas your username and password is correct. But it will not allow you to log in till the system is not ready. It will show the message in some time that, okay, system is ready now. Can you see? System is ready. Now, if I will put the same username and password, I would be able to log in. But what it is saying that this is now controlled by vManage. So even if I will go over here, if I will go in the system, and if I will change the host name, let us say I am just putting any host name. Okay, sorry. Here the host name command is host space, sorry, this colon name. And if I try to commit it, can you see what it is saying? This is vManage, so you cannot do it. Okay, we cannot do it. So this is the thing what I was mentioning you, that once your devices are up and it is managed by Cisco vManage, you cannot do anything over here. Even the host name need to be done from the templates, through the templates. Something there is named as templates which you need to manage. But yeah, once you would be able to understand about these concepts, when your fundamentals are clear, you will be able to do these things very quickly. Okay. Sure. If there are no questions, probably we are good to wrap up. Let me tell you, this course is approximately 20 or 20 hours plus course. Saturday and Sunday, 2 hours each day, weekend 4-hour class. Okay. Regarding the fees and regarding every other stuff, probably you can coordinate with Zoya, or Zoya will coordinate with you. Okay. So maybe she will able to tell you, all of you guys. Sure. If nothing, good to wrap it up. I would like to say thank you to everybody for joining in.